Hello, everybody, and welcome to the Wednesday night Arduino with Chris of MRL Trains. Arduino workshop for beginners, excuse me. But anyway, want to say go to YouTube modelbuilders.com. YouTubemodelbuilders.com. There you can check schedules for the Tuesday and Wednesday night shows. Those shows start at 8 o'clock Central, 9 o'clock Eastern Time. Check schedule for the Saturday live show and the Thursday show. Both of those are at 9 o'clock Central, 10 o'clock Eastern Time. And don't forget to click on the eMag while you're there at the website and sign up for email notifications. So when the eMag comes out, you'll be notified. And something else I was going to say. We got Thursday night show. Don't forget we got a Saturday live show this week. That's going to be this coming Saturday, so you don't want to forget about that. And I'm going to turn this thing over to Chris. So, Chris, it's all yours now.
All right. Thanks, Johnny. Welcome back, everybody. It's been a little bit since we've had a show, but here we go again with another Arduino for beginners by beginners. And I was hoping to have a lot more time to work with the Arduino the last couple of weeks, but I haven't actually had time to use it at all since the last show. So I guess we're really staying on the beginner's track here, which is what it's all about anyways. So tonight we've got Andy, Dave. I see Robert just jumped in. JD's not going to be able to make it tonight, or Ken. There's a couple more that hopefully will jump in here yet tonight. So what we're going to do tonight is to do something a little bit different. It's called a relay. And what this does is it allows you to use the relatively low voltage inputs of an Arduino. We all know we can't put a lot of power through an Arduino, but you can use this as a switch to turn on and off high power items, like you know, if you want to tie into your 120 circuit, if you want to use a lamp, or do some automation of things that you would plug into the wall. Anything that you couldn't, that's too much power to run through your Arduino, you can use the relay to do the switching. So the Arduino sends the relay the signal, and the relay then does the switching of the high power input and output. So it could come in handy in a number of ways for your layout. You might want to use it for automating lights or anything else that you plug into. I know some guys use it for automating their house lights if you want, but if you think about all the uses of Arduino that we've kind of looked at, sky's the limit if you get good at programming. So just think about how you could use a relay to do a higher powered items, whether it be, let's say you're running 12-volt lights in your buildings or something like that. And I'm hoping to get a little time, and I'll post them up online when I come up with some actually decent projects you could use it for. But in the meantime, it's a good thing to know how to use, and with a little creativity, it might really come in handy and benefit you. So with that, I'm going to switch my camera and we'll get started looking at one of these things. Actually, before I do that, I just have to warn you, I'm about to get hit by some nasty thunderstorms, so if I end up getting knocked offline, I'm just going to have Andy or Dave take over the show for a while till I can get back on. So hopefully that won't happen. But anyways, this is your typical relay. This is just a single relay. Let's see if I can get it to focus in a little better. There we go. It'll accept 5-volt input from your Arduino or any other device for that matter, a Raspberry Pi or any other device that can provide a 5-volt input. What it does is there's 3 little pins right here, 1, 2, 3, that are typical type pins we use in our Arduino projects. And one of them is for the 5 volts, one of them is for ground, and one of them is just for the input signal from the Arduino. So that's a very easy hookup. Then on the other end, this is where you put in your heavy duty wires. So you got the screw terminal connectors that allow you to plug in, like tonight we're going to actually have a little fun. I'm going to butcher up an extension cord and plug it into a lamp. And what we're going to do is take that simple little blink schedule or the blink sketch, and I'm going to blink a desk lamp using this relay and the Arduino. Just use it to blink the lamp. And then maybe if we have a little time, we'll get into maybe throwing together a quick breadboard with a push button or something and see if we can turn on and off the lamp using the push button. But, you know, that's really something you really don't need. We have light switches for our lights, but if you wanted to do some kind of programming like automatic on your layout or something like that, even room lights, you could gradually dim your room lights using the Arduino just according to a time schedule. Remember last week we used the real-time clock, or last show. So if you took the real-time clock and programmed it to slowly fade the lights in your room and bring up your layout lighting of dusk lighting, if you had it, that'd be a cool way to do it, automated. So anyways, this is just a single relay, and I'm going to share my screen real quick and show you. And even I know Dave happens to actually have one on hand, so we can let him show you that too in a minute. But let's see, here we go. So here's the single relay that I was showing you. That's the one I got in my kit. And if you guys bought the same kit, you have one similar. Even if it looks a little different, it probably has the same connections. But you can buy all the way up to like these 8 packs. This is 8 of those same relays, because a lot of times you need to switch more than one item. So you can buy 2 packs or all the way up to 8 packs of these relays. I did a little poking around today, and you can pick one of these up on eBay for like $6.50. That's not bad at all. That's less than $1 a relay. So, Dave, maybe you want to show them the one you have there?
Yeah, you can see on the screen right now. I don't know, am I centered there? That's basically the 8-pack right there. It's essentially the same thing as what Chris has, except they put all the pins together right here at the bottom. You can't really, there they are. You can see them down there now. It's basically the same thing with 8 pins on this side. You can see where you've got 8 separate sets of inputs and outputs. One thing you'll want to note is that you'll notice each relay has 3 sets of pins on it. One of the pins is for input, one is the normally open position, and one's the normally closed position. So
we'll be getting to that in a little bit.
Yep, it's just one of the things you'll want to know. Make sure you're aware of.
All right.
So that's
Thanks, Dave. Okay, cool. So, like I said, what we're gonna do is we're gonna end up hooking this up and trying to blink a lamp. And for those of you guys that want to work along, what I'm gonna do is I'm gonna give you a quick overview of this, and then Dave is gonna do a little sideshow on Mosfet, which is very similar to this, but it's just in a little electronic chip. It'll do basically the same thing. But well, before he does that, I'm going to give you a list of what you're going to need besides a relay if you want to work along with me. Then you can kind of listen to Dave while you gather up your goodies. So let's go over this quick, and then I'll give you the list of what you need, and we'll go from there. So as Dave just referred to, if you look at the screw terminals on here, if you look real carefully, let's see if I can get that to focus in. You'll see that one of them says NO on one side. One says COM, common, and the other one says NC. So the NO is normally open, and the NC is normally closed, and the common is always used. So the common would be basically where your power is coming in, and you're going to either connect one to normally open or one to normally closed. And what that means is, let's say I hooked up a lamp to this. If I hooked up to common and normally open, what that means is when there's no power on this relay from the Arduino and it's not getting a signal, that means it's an open circuit between the common and the normally open connection, which means your lamp would not work. It's just like turning your light switch and turning it off by breaking the circuit. So there's no completed circuit, your lamp does not light. And that would be the case whenever there's no signal coming into this relay. The other option you could have is normally closed, which means the lamp is on when there's no power to this relay. So that would mean if you had a power failure to your Arduino or any other reason that this relay lost power, that lamp would be on, or whatever I'd do hook up to it. So there are circumstances where you'd want that to be the case, and there's other circumstances where you want it to not be on if it would lose power. You know, in the case of a lamp, maybe you only want to turn it on when you tell it to by applying power to the Arduino, so you'd want to use the normally open. If you want it to always fail to a closed or on position, then you would want to use the normally closed. So that's those three terminals. It's a fairly simple concept. If anybody has any questions on it or as we go along, just jump in and ask. You know, we'll be free to, or we'll be happy to answer it for you. Else? So
Yes,
the question was?
Yes, there is a common ground on the Arduino side of the 8-pack, but on the relay side with the screws that you saw Chris pointing out, each relay would have its own input and normally open, normally closed outputs. Hope that answers the question.
And I put the wiring diagram for just the relay up on screen too, so you can see that you have an input and output going across a switch and a trigger. That's what's actually inside the block relay.
Okay, cool. Let's see here. Let's take a look at that. There it is. Nice. Okay, so back to just finish up on the relay, we had the 3 pins as I explained before. They're just 5 volts power and ground, which can either come from your Arduino or another source if you want. And there's 2 LEDs on here. And I couldn't tell you the function yet, what they're for, because I haven't actually used it. There's also, between there, real carefully, there's 3 of those, you know, sub-miniature surface mount LEDs. So I'm guessing those are probably going to blink to tell you when things are on or when things are off or when they should be on or off. That way you know let's say you hook this up to a lamp and maybe the bulb was burned out on your lamp and you didn't know it. If you're trying to troubleshoot it, if these LEDs come on, at least you know that the relay is getting power from the Arduino, and the problem would have to be somewhere from the relay to the lamp that's causing the problem, a broken wire or a burnt out bulb or something, or whatever other accessory you may decide to hook up to your relay. So we'll figure out exactly what they do when we get to that point, I guess. And I'm hoping there's guys out there working along that have your 5-volt relays. I think by now you should have been able to dig them out of the box and have them handy. So what I'm going to do now is just kind of give you a quick description of what I'm going to do for the program. So here's a cheap, you know, $3 extension cord. Rather than butchering up the cord on a lamp, what I'm going to do is I'm just going to butcher up this extension cord and then plug it into the lamp. So that way I'm not wrecking a good lamp cord. So if you guys have anything like that, a small lamp or something that you want to turn on and off with 120 volts of normal house power, you know, find yourself one of these cheap cords if you got one laying around. And all we're going to end up doing is, you know, these are the 2 wires that run through the lamp. All we got to do is snip one of these wires and peel it back and just tap into it. The other one stays intact. So actually, I'll just kind of show you how we're going to do that right now, and then I'm going to send you out on your parts search. So all I'm going to do just take my wire snippers, cut through at one point on there, and just kind of zip. It's kind of like zip cord, so I can just peel these back, and then take my big old wire strippers and, ooh, I might be a little big for this one. Here we go. Just going to peel back a little bit of that insulation on there. Geez, doesn't like this stuff. And that's why we do this live. There we go. So that's what we're going to do to start with, and then I'll show you how to tie that into the relay in a few minutes. But in the meantime, I'm going to let you guys go ahead, and some of the things you're going to need are a little Phillips head screwdriver just for, or whatever it takes to turn the terminals, the screw terminals on your relay. You might want to get yourself a wire strippers and a little something to cut it, as well as an extension cord and a little desk lamp or something. That's what I'm going to use. So while you guys go and hunt that stuff up, I'm going to have Dave explain to us a little bit how a Mosfet works in a very similar way, but it's not actually a relay like that. So take it away, Dave.
All right. What I'm going to talk about just a little bit is relays are great when you need to switch, really high current, and you don't need to do anything really quickly. Because there's a lag. You hit the power and the relay flips, and there's actually a mechanical operation in there that flips the relay back and forth. And so a relay is probably only good for the actual maximum you could flip it per second is probably 40-50 times per second, absolute tops. And that's great if you're turning on lights and things like that. But there may be times when you need to control things on the railroad at a much faster pace. Let's say you were trying to trigger some sort of maybe a campfire flashing or some sort of other mechanism that runs at a much quicker pace. You can use certain types of electronics. I'm sure we've all heard of things called transistors, as in the old transistor radio. What transistors are used for is basically taking a signal, amplifying a signal, and the signal that comes out the other end is much, could be a much stronger signal, can be a signal at much different voltage. I've got here, let me zoom in on this so you can see this a little bit better. I'm sure you've all seen transistors like this in electronic devices. What you've basically got here is you've got a power in, you've got a ground coming out, and you've got one line in the middle, which is a trigger. That's, you would take, like, let's say this middle line and run it to the Arduino, and then it would control the whatever comes in and whatever goes out. You would connect your power source or to one of these leads, and your load, whatever it happens to be, whether it's a light or a LED or a whole bunch of LEDs, you would connect to the other one. Now this, Chris mentioned Mosfet a little while ago, and I'll get to that in just a minute, because Mosfets are very, very similar to a transistor that I'm sure we've all kind of heard of and are kind of aware of what transistors are and what they do. And this is basically what they look like. A Mosfet is something just a little bit different. This is actually a higher powered Mosfet that I'm showing here. You can see it also has the same 3 legs that the transistor would have. One of them is going to be your signal going to the Arduino, and one is a power coming in, and one's power coming out. What I did here is I actually have a circuit built that's very similar to what Chris is going to demonstrate using the relay, but in this case, this circuit here, you can see I have a Mosfet lined up right here, and I'm going to back out on this. I'm zoomed in a little too close to make use of this. You can see right here, I've got 12 volt power coming in. This is actually 12 volt, and if you remember, the Arduino runs on 5 volts. This light that I've got behind it is a LED strip that runs at 12 volts, and it actually uses a whole 1 amp of power. As you probably remember from a while ago, we were talking about the output on the Arduinos, and the output on the Arduinos is in like 40 or 50 milliamps. So there's no way that it would ever be able to power this big LED light strip. And so therefore, what I'm going to do is I have preloaded on this Arduino. I loaded the Blink program that Chris was talking about a little earlier. So I'm going to try and get this pin here connected to ground to pin 13. And I'm just going to take a 9-volt power source and plug it in. And without turning on my light yet, we'll see that the Blink program is running. You could see the LED on here flashing once per second. And if I take a second now, I'm going to bend down, turn on my light. Notice how this is, I'm just doing this as a side note here. Notice how I have my line connected to the Mosfet, but notice the light is not changing even though the light is flashing on this Arduino. That's because I do not have a ground line running between the two. You can see the Arduino runs on 9-volt power supply. The light is running on a 12-volt power supply, but I only have this one little signal line going back and forth, and between the 12 volts here and the 9 volts here, they don't. There's not enough difference. The system can't tell the difference. So what I'm going to just simply do is take the ground, plug the ground in over here on the Arduino. Now you can see the importance of having a good ground in the whole circuit. Even if you have two separate, completely distinct power sources, you have to connect the ground together in order to make things work. You can see simply by plugging in that ground, the light started to work. If I unplug that ground, it stops working.
Yeah, that's a great point. I mean, there's other areas in model railroading where you're going to see that. If you add a second booster to your layout, if you ever read the manuals, you're always supposed to connect the cases of the two boosters, you know, your main booster and an auxiliary booster with a ground wire. Same principle. It's not going to function correctly if you don't. There's a good chance that it won't.
Yep, absolutely. I just thought I would take this opportunity to point this out, seeing as we are literally running on two different power sources. One is a 12 volt, one's a 9 volt, and it shows the difference of what this Mosfet is capable of doing is flipping that LED on and off using that. One of the other things I kind of really do want to point out, and let me turn the power off. I don't need that light flashing anymore. You notice the package that I used back here for the transistors. That's your standard transistor package, and a package is just simply how it's physically designed, how it looks. You can get transistors that look like this, that are much more high-powered transistors. This is, of course, one of these MOSFETs. And so you do have to look, though, real careful to see whether you have a resistor or a MOSFET. I also have voltage regulators that look exactly like this, and they're just a different part number, 3 legs, same thing. This package is called a TO220 package, and that's just physically the design of it. It's the black with this tab with a heat sink, because this is for attaching to a heat sink, and 3 pins out the bottom. But one of the advantages of using a MOSFET over a transistor is that they're much, much, much more
Robust.
robust. Thank you, Andy. I was looking for the right word for that. They can handle a lot more power without overheating. Transistor will overheat much more quickly than these MOSFETs will. This MOSFET is rated for over 60 amps of power. So that's 72.
Wow.
That's a lot of current running to
That's impressive.
60 amps. Right.
And a lot of very fast switching back and forth too. So There's a
Right.
lot of transistors out there. The typical transistor is called a FET, ferrite-rich transistor, but a MOSFET is a metal oxide semiconductor, ferrite-rich transistor. That metal oxide makes them just a lot stouter.
Right. Thanks for adding that,
Okay.
Andy. That's, Andy is very, very good with electronics. He's much better than I am, actually. And so
I doubt that.
oh yeah, I am dead certain you are, Andy.
All
I'm
right.
a
Well,
rank amateur beginner, so.
well, thanks for that little lesson on MOSFETs, Dave. And really, my takeaway from that is it really is a transistor. After hearing Andy talk, it's just a different, bigger, bolder, more robust transistor.
It's how much
That's
junk they put in it, basically. It's just a really dirty silicone, and the dirtier they put, the more dirt they put in it, and what type of dirt they put in it, whether it's metal oxide or ferrite or germanium or barium, determines its properties. So if you're going to buy one, there's a whole lot of them if you look online at the electronics distributors. If you don't have a high load or a high switching capacity, a cheap FET is more than adequate. But like music amplifiers for like PA systems, they're always MOSFETs because they can take a beating.
So the beauty of this relay, and I think Dave, you're probably right. Speed wise, it's probably not going to be nearly as fast. But the beauty of this relay is, using a transistor, you're going to have to add it to some other circuit where you're probably adding a bunch of other components. Where here, it's all ready to rock. You just plug in and go. You're not going to have to create a circuit on a breadboard. Depending on what you're doing. So
That's absolutely correct.
And a relay also gives you a physical disconnect, whereas a transistor, there is the potential for backfeeding of power if you do something wrong and you could fry components. It's possible, but with a relay, it's much less likely because you're physically pulling the wires apart.
okay. Well, I hope everybody's got all the goodies they need. If you found an extension cord and a desk lamp or any other 120 thing that you want to turn on, I don't care if it's a power drill or whatever it is that you feel like running, just bear witness to the fact that if you look on your top of your relay, like in my case, it says 10 amps. So it says 5 volts DC, that's the input, but then it says 10 amps at 250 volts AC, 15 amps at 125 volts AC, or 10 amps at 250 volts AC. Well, I'm going to be putting your standard 125 volts AC, so this will actually handle 15 amps, which is in your typical house, that's what a typical circuit handles. So, if I put more than that in here, not only going to fry this, but I'm going to trip the breaker on my circuit in my house. So, but you do want to check the one that you have and see what it says, and just make sure you don't exceed that load, or you could potentially fry your relay. If it only says 2 amps, don't be running 5 amps through it. So let's go ahead and gotta apologize. My dog goes nuts with the thunderstorms, so he's sitting here right by my side, getting up all in my face while I'm trying to do this. So sure, all you guys with dogs probably know what that's like. So let's switch back to my camera here. So what I'm going to do right now is I'm going to take one lead of this extension cord, and actually I should trim some of this back a little. That's just a little bit on the long side, so it's going to trim. Yeah, that was bright. Cut all them little copper shavings right next to my live Arduino. That was smart. So I'm just going to snip off, shorten up the little stub ends on here. So going back to what I did before is you have your extension cord. I just cut one of the 2 cords, peeled it back, and stripped the 2 ends. So at the end of the day, I'll have an extension cord that looks like this. That's all we really need to do is interject this little relay into the one cord of your one wire of your extension cord, and it'll act like an on-off switch. And that on-off switch is being basically triggered by our Arduino. So let me just finish opening up these terminals. I'm going to go ahead and use the normally open terminal so that if any reason this loses power, that the lamp is not on. But there may be cases where you want it to always be on unless told to not be on. Then you would want to use the normally closed. So all I'm doing right now is just getting up in here and put one in the center common and one in the normally open or NO terminal. Now you might want to be careful. I'm looking as I look in mine. These wires are actually kind of big to go into that. It's not opening up quite enough. Make sure you don't have one or two little strands that cross over and touch the other side, I guess is what I'm trying to say. So as you feed those in there and clamp them down, just look extra careful. Make sure you didn't get, you know, a strand from this side crossing over here that we'd get a short across the two. So this is what I ended up having now. Apologize for the poor camera work. So got my extension cord with the, you know, the normal plug end, and it's way too long, but and of course the other end. So now I'm gonna take, actually, you know what, let's just set this aside. I'll give you guys each a few seconds to get caught up on there. Hopefully you're working along with us, but in the meantime, if you're caught up, what I'm gonna do is start screen sharing to the sketch. We'll go ahead and load up the Blink sketch. So have your Arduino IDE open, and then to find the Blink sketch, again, we just go to File, Examples, Basics, and Blink. And go ahead and open up Blink, and then because it's ready to go, I'm just going to upload it right away. We are not going to change any of the code at this time. So as usual, I get to sit and watch it compile and then end up eventually uploading. Meantime, I'm going to mute for just a second while I guess I can't do that now. Got all these little copper strands that I snipped off are laying on my board here, and I don't want any of them to get into my Arduino and short it out. So. Just put the dog up here. He's panting hard enough from being scared of thunder that he'd probably just blow them all off there anyway. So, right, buddy? Yeah. All right, so mine says done uploading. And when I look at my Arduino, I'll see that light blinking just like Dave's was. So we know we're good to go there. So everybody who's playing along caught up. Anybody out in YouTube have any questions or working along that would like a minute or two? I'll be glad to wait if you need to get caught up. So what I'm going to do now is I was going to actually test the relay without putting the cord on it. So I kind of got ahead of myself, but I guess we'll just go ahead and do that anyways I'm not going to hook up a lamp at this time. I got to try and do some cord management here. This cord keeps trying to fall to the floor. So I'm going to get this to stay in place for a second here while I work on it. All I had was this extension cord, so it's trying to, other end keeps trying to fall to the floor while I'm doing this. So I'm going to grab a couple of our standard leads grab my pile of leads. We're going to look for the male to female leads. And I'm going to take one and connect it from 5 volts on the Arduino. In fact, I'm going to unplug the Arduino momentarily while I do that. And then there's a pin called VCC. That's where you will connect your 5 volts of power to. When you get done, it'll look like that. So I'm VCC on the relay, and I'm 5 volts on the Arduino. And I'll find my ground. See if I can find the black one in this pile. Here it is. Now, just like before, like always, we'll add one ground to the Arduino and one to the ground pin, which in my case is the middle pin on this relay board. There we go. And last but not least, we need to provide the input. So I'm just going to grab any color. I happen to have a blue one here, male to female. And just knowing, you know, if we look back in the blink sketch, we would see that pin 13 is the one that's being turned on and off with the blink sketch. Back and revisit and show you guys, but I think we've done enough of that on the past shows that everybody probably pretty much gets that. So I'm just going to put this jumper in from, I don't want to plug in very easily. There we go. From pin 13 on the Arduino to the pin called IN on my relay. So at this time, I'm not going to plug in my extension cord into anything. We're just going to leave the relay sitting here. And what it should do, I think, if we do this right, is you should be able to hear the relay clicking. I need a bigger work here. Many pieces flying all over. There we go. All right. So what I'm going to do is plug my Arduino back in. Oh, there it goes. Oh, that's cool. I'm going to turn this around where you can see it. What you see is that the red light is staying on constantly. I think that must be telling me that it's got power. And then the green light is going on and off. And you can probably actually hear that clicking. I'll get closer to the mic. So there it is. It's on every second, off every second, on every second, because that's what the blink sketch does. And of course, we know we can easily modify the blink sketch just by changing the delay times and stuff like that. So, oh man, you know what? I should have really looked before I cut into this cord. I cut in too close to the end where I have to plug into the wall, and not close enough to the end where it plugs into the lamp. So that's going to cause me some issues. So give me 1 second here to grab a second extension cord. In the meantime, I'm going to unplug this. So if I go plug that into my nearest outlet, it'll be too far from the camera. So grab me one more extension cord. Man, I'm really going to have a mess here. I'm waiting for the guy to invent wireless electricity. Get rid of all these cords in our houses.
You don't have to wait long. He invented wireless electricity in like 1910.
Yeah, I know, but it hasn't been. I shouldn't have said invent. I mean,
it's really hard to make. It's really hard to make money off of wireless electricity, though. So,
yeah, that's the problem. So here we go with my big heavy cords pulling my stuff all over the place. Ripped my wires right out of my Arduino. Hey, we're on a roll tonight. All right. We're almost there. What I'm going to do now is plug my lamp in. I'll show you the desk lamp in a second. I'll just reposition the camera. Big production. Okay, I just tried turning on the desk lamp and obviously it didn't turn on, but it shouldn't because it's on the relay. That's a good sign. Whoops. I just bent the pin on my. This is getting out of hand. Apologize for that. Too much stuff on too small of a table. Cords running everywhere. All right, so I'm going to go back and check this all. Plug it back in one more time, and then I'll show you the lamp of it. Oh, yeah, all that extra blinking, that's coming from the. There we go. So there's the Arduino. There's the relay. You can see the little green LED going on and off. And of course, you can see the desk lamp going on and off. So that's cool. It worked. Anybody else put one together and get it working?
Yeah, I got mine working now. I'm working on hooking it to a real power supply. I got it working with an LED through the relay.
Oh, and while we're
You know
doing
what's-
this, I got.
You know what's
Go
funny
ahead.
though, you guys? Chris, when yours goes off, Andy's goes on.
Yeah,
We
you
got
can't believe how much pre-work we had to do to get that right.
Get that perfect synchronization. That's cool. So while I was rooting around on the bench, I got to show you guys this. I bought this for my layout. Now don't laugh, because I got this at the dollar store, and you know what that is? Those are all fiber optic fibers. That's a little $1 flower, and I'm going to stop my blinking for a second to show you this. So if you guys have a Dollar Tree store near you, go get one of these for $1. And what I'm going to do is just show you the little switch on the back of it that you got to turn on. I don't know how good it's going to translate with the camera, but it's got a little flashing LED in the center. But yeah, there's the colors in the colors. It's really not coming through good at all, but it slowly changes colors and flashes. But you see the ends of the LED fiber optic strips lighting up.
Yeah.
So, you know, you can use, those are great for lighting your diesels or any other little marker lights on cabooses or whatever, you know, anywhere you want to make little signs for your layout. So I don't think you're going to find a better, cheaper source of fiber optic cable than $1 at the Dollar Tree. So you look at how many are on this floor. Signal towers, yeah.
Well, they're about the best for that too. With the when Professor Kleisler was on a show the other day, or a week or two ago, we talked briefly about some fiber optic stuff, and using real fiber optic, actual glass fiber strand, that's really hard to get much light out of. But he's done quite a bit of miniature electronics in HL scale vehicles and such, using that cheap plastic, which I would call a light pipe as opposed to fiber optic. It's light pipe, but it's totally usable for modeling.
Yeah, so I just, little sidebar, I thought that was pretty cool when I saw that. It's like, I know I've heard guys talk about using stuff like that, and then I saw that, it's like, well, I don't think you're going to get it any cheaper than that. So all right, well, that really went pretty quick. I think we got that done a lot quicker than I thought. So anybody out there in YouTube building along with us that needs a little help, or did you let us know if you got yours successfully working? I'd like to hear that too. Otherwise, no magic smoke. If I get the magic smoke, it's only, woo, there we go. It's like a disco. If I get the magic smoke, it's going to be because of right here. These connectors aren't, you know, I should have cut them maybe a little shorter, yet there's still a potential for those too. But if you were going to do this for real, I would lightly solder those strands together and put them in there so that there's no way they can touch each other. Because, you know, you're talking full household current here. So, all right, what do we want to do? Well, let's see. I think we could go back and I'll do a screen share. Let's just hack up our sketch a little bit and see what other cool things we can do with this. Meantime, I got to stop that blinking. It's driving me nuts. There we go. And screen share. Yeah, this would be a good time for us just to put our thinking caps on and apply some of the things that we did in past episodes, tie it all together. While we're on this page, let me just sidetrack for a moment. There. Real quick back in the beginning, but there was there's actually a page I found with the guy that I bought this kit from actually had right on the eBay page. It kind of shows you power for the relay, power the ground, power signal from controller boards, Raspberry Pi, you know, Arduino, and many other devices. You basically can use these with any device that's providing that 5 volt on or off on your output pin. This is the same thing basically with the normally closed. Or this was which one was this? Yeah, reverse connection he calls it. This is the normally closed. Connected device is powered on when the relay is not powered. When the relay is powered, the connected device will turn off. There was the old 8-pack there, and I had a couple links, but we're not going to get into those right now. So let's go to our Arduino sketch. With link sketch does. We've played with this enough times. So what I'm going to do is I'm just going to go ahead and make that 5,000. It'll be high for 5,000, and I'm going to make it 500, and it'll be low or off. So now I got to resave this with a different name because it's the blink sketch. So if you hit save after you make a modification, you're just going to have to say okay. I'm going to hit save. Unless the screen locked up on you, Johnny, maybe. Oops, I hit upload instead of save. It's going to, there. Done saving, upload. It's not doing that. There. It's not going to upload because I don't have it plugged in. I can hear the relay chattering away. Because the blink sketch is in, it's still going on and off, so I'm just going to turn off the lamp, let the relay click away, but the lamp won't be going on and off.
All right, we do have a question from Robert.
Okay, you got a question?
Yeah, Mike's on. I'm interested in controlling tortoises. Any suggestions as to which would be better, relay, Mosfet, or something else?
Personally, I would think that, you know, the relay, if you left it on all the time so that it wouldn't, I don't know if you'd actually would.
I would probably stay clear of, okay, keep in mind first.
Yeah, that's kind of what I'm thinking.
A minute ago was that relays are how the real railroad run all this stuff, but we want to not have to maintain them. We don't want to have to replace them, and unless you've got a whole signal crew of signal maintainers to go out and replace these things, they wear out. So I would, if you don't need the high current control like you do, like I'm thinking about controlling my power supply, it has 110 volts on it. That's perfect use for it. But for a tortoise control that's much lower voltage, you're much better off to use a solid state component like a transistor or FET or whatever, I think.
That's kind of where I was thinking too, because they when they're in their stalled position, they typically have power on at all times. The only thing you're really doing with a tortoise is just reversing the inputs to make it go back and forth. It's called a stall motor because it's got power on all the time, and it's actually drawing a small amount of power at all times. They don't have a real high load, but you know, when you flip the polarity, then it switches and moves the other way until it stalls again. But it's always on, and you know, it's not like it turns on, moves over, and turns off. The power is always on, and you're just flipping the polarity to make it go back and forth. So I don't know that a relay would really be useful at all.
And even if you did use a relay, I think you would need two of them, or you would need a relay that is a double pole relay.
Most of the time, if you're going to control a tortoise with something other than a toggle switch or a push button, you're going to be using like an NCE switch it or something else. A decoder more than likely is what you're after if you're not using a plain old switch. In which case, those already have everything on them that you need to, you know, power down or provide the power to the tortoise. I mean, you provide auxiliary power to the tortoise, but then they command it to go back and forth. The switching is done right within that. It's actually just a decoder, you know, a stationary decoder. but that has all the proper components on board already. So, you know, it could be done, what you're asking. I don't know if there's a real use or a need to have to do it.
If you wanted to use an Arduino over using an NCE, like in my case, I don't have an NCE DCC system, so Arduino makes the most sense for me to control all mine. If I was going to do stall motors, I would do it with transistors, and I would use 2 of them. So I would have to, I would basically reverse the flow of current by throwing each one in one direction and then flip them and throw them the other. So there's a way to do it. You have to build a small circuit or buy a small circuit. It's not a single component solution. It's not a lot of components. It's a very small handful of components, but it would take a couple things.
Yeah, somewhere in that circuit, you need something to reverse the polarity, but keep the power on.
Yeah, basically what you want to do is just switch the power on in a different direction. And transistors are really good at handling that that need. So what you would do is flip resistor, and this off the top of my head, but you'd flip the resistor for the flow this way on, flipping the other one off. And then when you wanted to flip the turnout the other way, you would flip this transistor on, flowing the current back that way, and this transistor off, and they would be tied together so that when one was on, the other was off, or vice versa.
Okay. So I hope that answers your question. If not, we'll take another stab at it. Just repost it again in a different way, and we'll take another stab at it.
Yeah, Dave, I think transistors are probably the best bet. You wouldn't need to use a Mosfet or anything like that because the current that goes through there is actually quite low. I don't think they use very much power. No. And so, yeah, you'd use a transistor
like this little guy right here. You could buy like 100 of these for $2 or $3.
Yep.
So you need a couple of them and a couple resistors and stuff to make your circuit work. And if you would, and to put a safety precaution in, you might use a diode or two, so you made sure that the current only flowed in one way or the other. You can even do it with a single trigger off from an Arduino, so that when the Arduino was on, by using a diode, when the Arduino took a pin high, it would flip this transistor on, and when the resistor went, or when that pin went low, it flipped the other resistor on by using a pull down resistor. That's you know, we probably need to talk about pull ups and pull downs at some, you know, on some future show, but.
Yeah, I think we touched briefly on it once, but that would be a good thing to go over again, because that's something that is very common whenever I read through not only Arduino stuff, but I've been doing a lot of research right now on block detection and signaling. Now that I have my main line up and running and I need to start wiring, I want to prepare for that. And yeah, pull-ups, you look in any of the documents for any of the electronic components you buy from like Railroad Circuits or Team Digital or Digitrax, you're always seeing reference to pull-up and pull-down resistors.
When NJ International signals, for example, are common power, and you switch the ground to throw the signal. So you have to use pull-up resistors to actually be able to trigger the ground to throw the signal. And that took me a minute to figure that out, but pull-up to pull-downs are, they're all pull-ups. That's what it is, a pull-up resistor. You're pulling the ground, you're pulling it up to positive until you flip it to ground, basically. So
right, but you also have pull-downs, which do the opposite. They make sure when it's off, it's pulled to ground because of straight currents that are less.
Mine are pull downs effectively, but it'd be easy to cover in one show because they do the exact same thing. It's just a matter of where do you want to pull the power to in its default state, kind of.
I'm wondering if maybe this is a good topic for one of these weeks, is maybe to show how we can do a Arduino controlled tortoise switch. And Andy, you've got some good ideas on how to set up the circuitry.
Yeah, I mean, that was just my first thought. If we're going to do a show, I'd think about it a little more than that quick gut instinct. But I don't think it's not a hard thing to do. So,
no, I agree with you, and I think that might be a good show because it would be very relevant to the topic, I think.
Yeah, and I was adding that second part about, I mean, if you put a diode between the two, then you could trigger it with one output, could trigger the tortoise, make it go one way or make it go the other way, just on whether it was high or low. Yeah.
So let's take a quick poll of the YouTube audience right now. I know, bear in mind, I am still preparing for a speedometer project down the road. That's definitely still going to be something we do. But in the meantime, we'll have a couple shows we need to do. What are the topics that you'd like to cover? Whether it's rehashing something we did or taking it to the next level, or something new that we haven't touched, John. Just post up in the chat on YouTube real quick anything that, you know, Johnny, I'm hoping you can see that chat and just take
Yeah.
a straw poll of what you see for answers.
Yeah, I'm watching. Tab in Maryland said look into H-bridge circuits to stay with solid state components for the torque
Okay.
switching.
Yeah, we kind of touched on those briefly, but we didn't really get into them. That was one of the options, if you remember. It was the H-bridge or the, I keep wanting to say Darlington, but I got transistor on my brain. I don't think that was it. Yeah, one of the shows we briefly mentioned it, but we didn't really get into. It was one of the two options. Which one was it? Somebody help me out here.
I must have missed that show where we talked about it. I'm going to use an H bridge to build my own boosters. Basically, they're high V transformers using H bridges.
Yes, so much has gone by in the last month that my brain is just a mush. So, all right. Anyways, what I'm going to do is just real show you. Let's get back on track for a second here, so I can shut this relay off. Digital write high to 5,000, which means 5 seconds, and digital write low to 500, which is half a second. So what that should do is light up the lamp for 5 seconds, turn it off for half a second, and then in the void loop, it'll just keep doing that over and over and over again. So let me stop sharing, bring you back up camera. Oh, there we go. And I'll just reach over and turn the light on. Actually, I had that backwards. This is a low input, so it goes off for 5 seconds and then just flashes for half a second. See, there's this half, and then you count up to 5, and you'll see it. And if I would change that the opposite, if I would have made it high for 500 and low for 5,000, then it would have been on for 5 seconds and off for half a second. So I could do that.
No, that won't change the code.
Well, no,
the code's still telling it to go off.
no, but what they're saying is if I went to normally closed from normally open,
Oh yeah,
that would turn the light on without changing the code. That's cool. Let's do that just to prove it to you. I'm just gonna turn off the lamp, unplug it. Remember, guys, we're working with much higher voltages now, not just playing with a little Arduino. So if I just take my little screwdriver here, I can leave the common in the center. All I'm going to do is the normally open contact. Actually, you know what? I should probably unplug the other end of this too, because that is still live.
That's awesome. My transistor doesn't my relay is not both ways. It is only a normally open transistor. All right, relay.
Oh, bummer. You can't play along. Yeah, I'll get to see it though. Go ahead.
I just get the feeling Andy's been there, done that.
Oh, I've done about everything you can do with 110 plus volts, including.
That was a good idea, just to show the versatility. Whoever posted that up, I like that. So I'm gonna. So first, I plug that back in. Actually, I should unplug it. Let me get the Arduino up and running first. You hear it going nuts. You hear the relay clicking. All right. So there went the light. So we can see, if you watch the relay, watch the little green light there, it's on for half a second and off. That's what my lamp was doing before, on for half a second, off for 5. But by switching to the normally closed, remember what happens when you're normally closed? That means it's going to be on until told otherwise, which means every time the relay trips for that half second, it's literally going to turn it off, and then it's going to be on the rest of the time. So here we go. Let's test that out. Makes good sense. It should work. Let's try it. Okay, so
It'll work. It'll work.
now it'll work after I plug in the lamp into the other end of the cord. There we go. And then I got to turn that on. There. Okay, so we're on, off for half a second and on. So that's exactly what it did, because if you watch the green light on the relay, it's off right now, but the lamp is on. But then when the green light on the relay goes on, which means the relay is being activated, it's turning the light off instead of turning it on. So, perfect. So without changing the code, we were able to do the opposite effect just by switching from normally open to normally closed. Great way to demonstrate the difference between the two. Was that your idea, Johnny? Awesome. You rock. You need to be on the panel. Oh, wait, you are. All right. Oh, I see Chris Rude jumped in. How's it going, Chris? Must be muted. Yeah, I did run across those in my research, but I didn't have time to read about them. But yeah, what he's talking about, a relay shield, you can buy shields that just plug right onto the top of your thing here, and they can have maybe anywhere up to,
I think they have
I don't know if it's
4.
1, 2,
I think they have 4.
1, 2, 4. Yeah, I'm not quite sure because I didn't have a lot. I didn't really get into depth in reading about them, but yeah, they can, instead of having a separate relay, you can actually have some that are built right onto a shield that plugs right onto your Arduino.
Yeah.
And I think they also give you additional ways to run outputs right out, and they have LEDs built on them and everything just like this. Because, you know, what Andy was talking about, not only his is only normally open, but his isn't on a circuit board like this either.
No.
You know, mine came with this nice little board with the LEDs and the pins and the screw connector terminals. His is just flat out basically like this blue box that's on here, right? So all he can really do is he's got a couple pins, and I think it was a standard pin that could plug into a breadboard, but
Yep.
literally that's all he could do is plug it into a breadboard, and from there he had to jump her out to all the different places, and it didn't have the nice little LEDs on it to verify that it's working.
And that's why I had that diagram handy. I had to go look that thing up to see how it was wired inside. Because, I mean, all you got different is you could choose between normally open, normally closed, the LED, and those fancy screw terminals and stuff. If you're building a permanent project, this is the ticket. For testing, what you've got is perfect.
So I'm looking at here too while we were talking is, okay, remember I talked about the LEDs. So the red one is obviously power. One in back here that doesn't, there it is. So this one is just telling you that there's power to the relay. As that's W when it switches on, because we only have it switching on for half a second. But I still don't know. There's these 3 tiny little LEDs. Unless those are just bridged connections. I thought they looked like LEDs, but my glasses ain't. That's a little small for my eyeballs. So, all right, I unplugged the ground. Nothing happened. They might not actually be. They might be just soldered bridge connections, but they sure look like they could be tiny little LEDs. Not sure. If somebody else has better glasses than mine, maybe they could take a look at theirs and see what they think, get a second opinion. But
Yeah, unfortunately on my 8-pack, I only see 1 light per switch, not 2. And the lights would light when it's closed.
Okay. So, is there anything you guys really want to do? Otherwise, I think, Johnny, did you get any answers on what people want to do in the future shows? I think I might just cut this short or turn this into just an open forum for the rest of the night. I was thinking of doing like a push button or something like that, but I think everybody pretty much gets the idea of what this relay can do for them. And you could combine this with any of the other programs we've done or projects we've done so far. That anything that needs higher power, would you like think about controlling it with push buttons, or you could even have an LED display that comes on and tells you your lamp is on, or match this with just about any project, as long as you have something that has a higher amperage, higher voltage draw than the Arduino can provide. Then you just go through the relay and do it.
Martin down in Australia, he said, what about TFT screens for video animations?
That would be cool. Were you on mic on so they could all hear that?
I haven't got one of those yet.
Johnny?
TFT screen.
Johnny? Yeah, I haven't either. Johnny, did everyone in the audience hear that, or do I need to repeat it?
No, they heard it. I got the mic open.
Okay, good. Yeah, I don't have one of those. I think what he's doing is basically talking about a touch screen. The TFT is basically a touch screen.
I'm going to get one of those, though. I wouldn't care to order.
I don't have one.
Do a show, I would order one and play with it, because what Martin's doing is really fascinating.
Also, Robert has tortoise control, looking at JMRI, CMRI interfacing using Arduino instead of CMRI hardware. Seen many approaches, but I'm interested in the trade-offs of different approaches, not just in the hardware.
We're working on CMRI. There's a group of us that have been playing with it in regular chats and spending way too much time on our own messing with it. I think once we get up to speed, and I know Chris has been talking and messing with it too. I know that once we get up to speed on it, that may be good material for a series of shows, because it's pretty neat.
So here's some of the other components. I'm just going to start setting out here that I got with my kit that we haven't played with, because we will get to, but I wanted to keep this model railroad related. But if you guys are interested, we can go off on a tangent, look at some of these other things, like this ultrasonic sensor. It gives you distances using ultrasound. And this one I did actually use. I think I mentioned this on a previous show. One of the first things I did when I bought this kit, before I even started thinking about doing this show, was I actually set this up and was playing around with it. It was really cool. You're walking around the room, and as you get closer to a wall, closer and farther, or you could set it down and walk up to it and walk away. Your serial monitor would tell you the distance. Now we could combine that with the LCD display, but I do like the idea of the touch screen. And another thing that I didn't get with mine that would be totally applicable to model railroads would be one of those little mini MP3 players where we can record our own sounds and then activate them with the Arduino. So you put little sound files on an SD card and play them with your Arduino.
Yeah, it's pretty low quality. We've been talking about that in a sideshow chat as well, and a few of us are doing a thing using Raspberry Pi Zeros, which are like $10 boards, to get audio, because they have good, 16-bit or higher, fairly high quality audio. The Arduino is pretty good for like the bell ringer for a crossing flasher, but anything much more than that, they really start to suffer at sound quality.
Well, my thought was something I want to do for my railroad is actually flange squeal. I want to set up some kind of a sensor, probably an infrared sensor between the ties, or maybe just a block sensor,
I'm doing it
when
with
I'm
blocks.
going through like the horseshoe curves that, you know, that would play the random flange squeal sounds until the train is out of that block.
Yep.
You know, it slowly fade in and slowly fade out and just play random flange squeal noises. That would be kind of cool. And that wouldn't be hard to do at all, but you need that little sound player to hook to your Arduino.
Well, you've heard me talk about that before. I've been playing it on flange squeal sounds and stuff since I first started this layout as well. Me and you have talked about that several times. I'm going to do that as well. I'm using block occupancy current detection to get my flange squeal notification. And I'm going to use Raspberry Zeros because they're literally like $10. And then I'm using these little Bluetooth things. This is one in the case. This is one out of the case with a screw terminal, 1/4-inch plug. This is a Bluetooth transceiver module. It can transmit or receive. So you can take two of these and pair them to each other and send audio wirelessly. And then you can get these external sound cards and plug up a dozen of these things in a USB hub to a Raspberry Pi, and you can have a dozen different speakers hooked to one Raspberry Pi, and it would be high quality audio. And flange squeal is high frequencies are sensitive to low quality audio. So my suspicion is the flange squeal would sound pretty digital on a Arduino, but we ought to test it to see because I don't know.
Yeah.
All right,
for the
got
sake of
another
this
one
show,
here.
it is an Arduino show. So.
Got another one here from Dan BM Man. The one thing I would like to see or know is if the Arduino can work with the LocoNet and JMRI. I have a modular project that could benefit from the combination.
And it could be a deep
Okay, so
coder. Look at Dave Barraza's work on YouTube Model Builders, or on Model Railroad Hobbyist Forum. He has done quite a bit of work on making a DCC accessory decoder using an Arduino hooked to the DCC bus. But that stuff that the guy was talking about in the chat a minute ago, the CMRI stuff, is a much more advanced version of JMRI and Arduino control.
Right, but back to it. But his question was the LocoNet, which is Digitrax, and I know there was. Matter of fact, I'm glad you brought that up because just yesterday I scored one of those great occasional scores on eBay. I managed to pick up a local buffer USB, which is Railroad Circuit's version of the PR3 for creating a LocoNet and connecting it to JMRI.
Yep.
$12 plus $6 shipping. So for $18, I'm getting a $64 local buffer.
Yeah, those are all
supposedly unused in the package. So I'll be setting up a LocoNet to try that out. I have successfully set up the CMRI net network instead of a LocoNet, so I know that worked.
All right, Martin down in Australia said maybe ultrasonic occupancy detection. Dan BM Man would need 4 IRFD sections. And Robert wanted to know, doesn't the players have their own amplifiers?
They do, but and I'm no expert on this particular field when it comes to audio quality. I just did some reading on it some time ago, and from what I understand, the Arduinos can only work at the frequencies within their range, and the chip that's in here puts out a frequency of whatever 300 megahertz, whatever it is, and a multiple of that, according to what I understood, could only do 8-bit audio. But I would have to do some research to find out because there's no real reason why it couldn't do high quality audio. It's just that the modules I've looked at all seem to be all 8-bit audio, which is fine for low frequency sounds.
All right,
but high
let me
frequency
behave. I'll be back.
I made it. I'm back.
Actually, I'm sitting here thinking that it's, you know, if you wanted to use some high quality audio, you might be better off using a Raspberry Pi or something like that.
Yeah, that's what a few of us in one of the sideshow chats that we're talking about using Raspberry Zeros because they're you know, and I've got one already set up. I've been starting to play with my audio effects as well, and I've got a Raspberry 3. I got a whole bunch of these, and I'm building the camera system for my layout with these. But they've got audio outputs, and then you can also get these little external sound cards. This little Creative Sound Blaster sound card with an input and output, and you can plug up to a USB bus, a USB hub. You can plug up, you know, a dozen of these things, and have you know, have all kinds of high quality sound, and have a whole bunch of different sound outputs. And with the Linux that's on here, you can have it put that squill in and play it on this sound card, and then this sound card, and then this sound card as your occupancy detection follows along.
Can you guys hear me?
Yes, sir.
Yeah. I think we did do a while ago. Wasn't that JD that did was that JD or you, Andy, that did a little thing on ultrasonic sensor?
I think
Way
JD
back when.
did something with it.
Yeah, way back when, in one of the first couple of episodes, he did a little thing with that.
Yeah, somebody did, and I like the ultrasonic sensor. I would like to learn how I could use that in a valuable way too. This is a really interesting sensor too. You can buy these for a few bucks. It's called a PIR sensor. I'm going to put these in the fascia of my layout to detect which humans are in the aisleways, so that I know which sound effects to focus on my layout, so that the creek sounds and birds chirping and all that ambient audio is not so noise polluting. It only plays the sounds that you're close to. And these PIR sensors are like $1 or $2. And they're the same kind of contraption, you know, a couple outputs, and they will give you a sensitivity or give you a number between 0 and 1023 or something about how, you know, if something's in there. So I'm interested in either of these sensors a lot.
Can you guys hear me now?
Okay.
Yeah.
Yeah, I heard you.
Because I was talking,
Me too.
nobody was letting me talk, and you guys couldn't hear me.
Oh, I got knocked out. Must have been the storm I predicted. But I just wanted to finish that Digitrax answer real quick, and then we'll get back on this. But I don't know when I dropped out, but I was there is a guy out there that wrote a library for LocoNet. I haven't tried it yet, but I like that idea. And as Andy referred to too, we've got some guys working on CMRI for, you know, the network for that. But yes, the short answer is yes, it's doable. You just get out there and Google it. The long answer is no, I haven't done it, but it's on my list of to-dos.
And I would like to answer on top of that the other question with the CMRI bit. I understand there is different ways to get the output out of JMRI, but the CMRI is, if you're just talking strictly Arduino, is probably your best bet, because when you start doing the other methods, such as if you're using a Raspberry, using the GPIO pins or whatever, that gets into advanced scripting within JMRI. So that would be kind of beyond what we're doing, I think, here. So
yeah, and even the LocoNet, I think you have to buy a shield, if I'm not mistaken.
Yeah.
You know, it isn't just a library. You have to actually buy a shield for your Arduino. Well, when you start adding that kind of money, you might as well just buy a PR3 or a local buffer and stuff that's out there. But with the CMRI, exactly right. It's perfectly suited for Arduino.
yeah, and part of what Andy said, we're working on a couple ideas here to get that to work a little better. We have a couple of theories on that as far as communications are concerned and stuff. So we are working on that. So
shoot me a message if you're ever working on it one night.
Yeah.
You know.
So
I mean, get in on it.
Yeah,
it's
absolutely.
not for the faint of heart, though. Right now, at least, as you know, hopefully we will get this optimized down to where it's a more exacting science about how to do it. But for right now, it's not for the faint of heart.
It's definitely a hot pain in the rear.
Yes. Now, we're gonna figure it all out, hopefully, and hopefully, you know, all of us together will put together some really interesting shows and show you how to get past the stuff that's causing us some difficulties. But
and to build on the cheap.
Yep. Yeah, we got a real good plan. We've been talking about one of the off-channel shows for doing it, where we don't have to use that god-awful RS-485 bus to allow a bunch of Arduinos to talk to each other, where we could use a bunch of $5 Raspberry Zeros to do it and stuff. We've got some really good ideas, but you know, the thing about a lot of this electronic stuff we're talking about is great ideas are fine, but you got to put a lot of legwork in to turn those great ideas into working, working turnouts or something. So,
Mm-hmm.
Yeah.
Yeah. There's a lot of beta testing that has to go in.
So
yeah.
here's one other little cool thing that came in my kit. It's a little joystick. You know, I wonder if we could use this for, you know, I'll look in to see if there's a sketch or a program or if anybody else wants to too that, you know, maybe we could actually run a train with this or something, you know.
Oh, I'd love to build hey, there's a guy who's done a little bit of that legwork. I want to build a throttle for my DCC++ with an Arduino, and with that, I would love to take that little rocker and do something smart with that.
You know, and you might even be able to throw turnouts with it or something too. You know, I don't know. I haven't done anything with it yet, so that might be another good future show.
Sure, that'd be cool.
Plus, we got these other digital screen, but you got your straight digital, and I don't know what do they call this, light pipers or
Matrices. They're LED
yeah, the dot matrix, but there's another
Yeah.
name, light tube or something like that they call it, or
Light pipe.
yeah,
Well, light pipe
So-
is what that fiber optic thing is that you have.
right.
You're talking about that.
But these they
little-
call like a light,
That's
the dot matrix, but there's another name for it, like light
yeah,
tube or something.
like a light panel or something. Yeah.
Yeah. Try some of that too. We're going to need that for the speedometer. We're going to need a digital display like this for our speedometer. Or we could use the LCD that we've already used.
Yeah, I have one of those like Chris has right there for the speedometer.
Other than that, I'm just kind of looking at there's a sound sensor. That's, and of course, and there's a digital sensor. I don't know what that would be good for other than to buzz an alarm if it gets to be too cold or hot in your a humidity sensor might be cool. I'm sure they're out there. And then of course a real-time clock we already used, and that's most of the components other than infrared. You know, they give you this little remote, and then we've already played around with the IR sensors, but you can actually do some programming that trigger things using a little cheap remote. It doesn't have to be that one. It can be any old TV remote you have around. You consider walk around layout and turn stuff on and off with infrared in your Arduino. Yeah, that's right. I forgot all about that one. Yeah, RFID. You can turn stuff on and off by swiping, just like there's actually a card in there, just like you could tag your rolling stock, you could turn things on. I actually thought for turnouts, you know, you get these little key fobs like this. You put a little IR detector or whatever the other half of it, you know, the circuitry by the switches, and the guy just just swipes his key fob next to it, and it'll throw the turnout. No facial buttons needed, you know. And it could be built right underneath the scenery that you wouldn't even have to have anything showing. You just swipe in a certain spot, and you could put it behind the fascia. I'm thinking it would still work too. They'll go through a pretty good amount of thickness, I think, more than the thickness of a 1/4-inch masonite, that's for sure. There's some more ideas, stuff we can play around with. All right, so
All right, we got Dan BN Man. Would it be possible to make an Arduino indexer? I guess like for a turntable.
oh, I would think absolutely.
Yeah, using a stepper motor.
Yep. We already did the stepper motor. It'd be just a matter of programming it correctly and having some kind of an input to tell it which way to turn and when to stop. That would be cool. If there's enough interest, that might be a good little project, you know, because that's more than a one-nighter probably. We could actually make a little project, a 2-night project out of that if we dove into the code enough. and actually built one. Or even it's just a stepper motor and a piece of cardboard, but just to prove the point, to actually build a fully functional one rather than just play with the components that it would take to make one. That might be good, something to do after we do our speedometer.
Yeah, he
Like
said
that
for
idea.
like turntables and transfer tables.
Yeah. Yeah, because we had those stepper motors are so much more precise yet than the servos. Not that the servos aren't precise, but the stepper motors are that much more precise and repeatable and smoother. I was really impressed. I never really used one before we did that. When we did the show on one, I was really impressed at how well those work.
Yeah, they're pretty handy.
If it wasn't
Handy
for the
or
fact
Andy?
that wasn't for the fact that it would probably be a little more work to, if they had a simple spline shaft and hundreds of little arms and wheels available to stick right on them like servos do, I'd almost think about using those instead of servos. But then again, servos have a little slop, and that's good because you want to actually push a little harder with that stepper motor. If anything shifted even just a little bit, then pretty soon you're either pushing too hard and breaking things, or you're not closing completely when you throw your points. So, that would have to be dead accurate every time, where you can actually overthrow it just a little bit with the servos to always keep the tension, but not too much that you're breaking things. Any other good ideas out there? Dan's full of them tonight. The local net and the turntable.
No.
I'm guessing that's Dan. I remember that part of the name.
Yeah, I understand.
Okay. So, Dave and Andy, when I cut you guys off, you were talking about the sound and the Raspberry and it's Pa for Andy, so split the difference somewhere.
Well, I think Andy's
I think
already
he
got
must have won.
some examples where he was working on that. So
Yeah, that's when I got
he was
booted
using
off.
the Raspberry Pi for that instead of and he was using the Pi Zero, because the Pi Zero is only like $10 or something like that.
Yeah, I haven't dove into Raspberry Pi yet.
What are you
Sounds
building,
like
Dave?
Pardon?
What are you building?
Me?
Yeah.
Not much. I just kind of play around with with various things.
Oh, okay.
Well, let me poll the audience, both the panel and the YouTube people. How many people actually have a Pro Mini or a Nano or something other than the Uno? We should each just go ahead and order a couple and because that's really the way to go at the end of the day. The Uno is great for testing things like we're doing right now, prototyping, but when you actually go into production and want to start mounting these things on the layout, I think those little Pro Minis are the way to go, and they're only a couple bucks. So I'm thinking maybe why don't we just tell everybody to run out and order a couple of those that we can actually build permanent things and throw them on the layout. But I haven't actually used one yet, so I want to see the difference on how to. It's not as straightforward to load.
Burnett
your
42 says he does. Robert, that's in here, he said he's got Mega X2.
Oh, there we go. Mega would be another thing too if you really want to get the outputs. Instead of putting a bunch of Pro Minis around, you go with one big Mega and send wires all over.
The Mega and the
size of your
Uno
layout.
the Mega or the Uno are the same. It's just that you get more I/O pins, but you also get more communication ports also.
And
Right.
Greg,
So if you had a smaller layout.
Greg
Sorry,
Hines
Johnny,
said that I have a turntable set up I can show once I get my webcam. So.
Well, that would be great. Just email me mrltrains@gmail.com, and I'll be glad to get you on the panel when you're ready to go. You just let Johnny or myself know. Yeah, on here. That'd be great. Anybody else have a project they want to show off? Even guys out on YouTube that are watching along.
Nigel's
railroad related. We'd love to see it.
Yeah, Nigel's got a good question here. Why is the relay chattering when you first turn it on? Does it need a diode?
Probably the best thing to do would be to not plug it in. But what it's doing is, if you ever notice, every time you plug in your Uno, even if you have nothing connected to it, you see those little LED lights flashing all the time. It's just establishing communication, and
Basically, it's booting up.
It's booting up.
It's
And
booting
because
up.
we've connected to pin 13 using the blink sketch, LED on pin 13 is one of the LEDs that flashes during the boot up process. So by moving that to a different pin, we would avoid that. Just took the easy route to minimize the wiring tonight and just use pin 13. But if we wanted to use, say, pin 7, it probably, my guess is it wouldn't do that, because I don't think the pin 7 would be affected by the boot up like pin 13 is, only because pin 13 is connected to that internal LED.
And I think you're basically
if
right.
anybody
Yeah, Dave. What
was
was
better-
that, Dave?
Yeah, Chris, I think you're basically right, because when you plug in the USB port, it's communicating with the computer, and if you watch that light as you plug it in, you'll see that it does flash back and forth a couple of times, and that's because it is a status light. And if you did go to a different pin, that would not happen.
Just be sure and change the pin number in the code.
Yep.
Correct. You'd have to go into your code and change the pin, the output. And so it was just because we wanted to take the quick and easy route and use the already written blink program.
Now, Chris, I know you mentioned a little bit earlier about going out and getting some Pro Minis.
Yeah.
There's a place that I go, and I find a lot of electronic stuff, just parts and gadgets and gizmos, and they really have a whole host of different various things, and it's cheap. I'll admit, the stuff is cheap, and the possibility of getting something that's not quite right, might be. But what I do is, I get these, they're so cheap. Like, for example, I go out to it's called banggood.com. It's a place out in China. Here, I'm sharing my screen, so Johnny, if you want to share that with everybody. You can see, like, right here, there's 5 Arduino Pro Minis. They come as a kit for $12.99. I've ordered from Banggood myself probably 5, 6, 7 times at least, getting a whole variety of different things, and I've actually been very happy with the speed with which things come. Last time I placed an order for stuff from Banggood. It came from China and got to my house in less than 7 days. So it was really quite good. And they've got basically everything that you could possibly look for. Yours, it's Pro Minis, but I don't know what you want to look for.
It's essentially China's Amazon.
Yeah,
okay.
It is. And
I've ordered a bunch from them, and they have local distributors. So I ordered something from them. They must. I don't know this to be the case, but they must, because I ordered something recently from them, and it was like $1 or $2 free shipping, and I had it either the next day or 2 days later. And I'm in Kentucky, not New York City, so they had to have a local distributor.
yeah,
Cool.
so I actually.
So Dave, if we order the Pro Mini, what do we need to go with it? That's the point I was going to get to, that we kind of changed subjects before I got to it. But
Yes.
if we order the Pro Minis, do you need something to load your sketches with?
Yeah,
Like
you
this
need it.
FTDI interface, which is just pins to a USB.
Everybody, then they can.
Here's I'll bring this up. This is an FTDI from Banggood. It's $4.72. You see these pins here plug into the pins that would be on the Arduino Pro Mini. You plug your USB in one end and plug this into the Pro Mini, the ports should match, and then it programs the Pro Mini. The Pro Mini gets its advantage being small and can be mounted on a circuit board very easily, and that's because it does not have the USB connection. That's why you need this FTDI.
Right.
Yeah.
So is that a full-size USB, just to get a scale of what that picture is?
Oh,
Or is that a
it's,
mini USB?
No, that's
It's a
the mini
micro.
USB.
Yeah.
Right.
Or
Like
big,
you use for your cell phone or something?
a cell
Yeah.
phone is often a micro. This is a mini, so
Okay.
it's the same width as the same thing you charge a cell phone off, but it's a little fatter.
Okay.
Yep.
So do you need a special cable, or does it come with that, or?
No.
I mean,
Let me
if
show
you don't
you
have
what-
a cell phone cable, do you have where do you get the cable for that then?
They would probably have a mini cable for 99 cents on there.
This is that FTDI board. This one I think I got from SparkFun. I bought 2 of them, and here's a Pro Mini mounted on the board. You basically, if I wanted to program it, I plug the FTDI into the Pro Mini and take my cable, plug it into here. Let's see if I can actually do this.
USB always goes whatever direction you try it first. It always goes the
Yeah,
other.
it's the other way.
Yep.
I hear that. The only thing I like about Apple is that lightning plug, because
Yep.
you
Or
can't get it
USB.
wrong.
I have USB-C now. That's awesome too. It goes either way.
But anyway, you could see that this is how you program it. Then you actually have to provide it with a power source. You have to provide your Pro Mini with a power source. So in this case, I've got a power thing on the back end. I can plug in a 9-volt battery into here. That's just I should zoom out just a little bit.
Okay, so if you were going to put that Pro Mini into production, so to speak, mount it somewhere on your layout.
Just tie it to your bus. I have a
Yep.
5-volt
Right.
accessory bus run through my layout. That's what this powers. This is 5 volts. And that 5-volt bus, I could hook a whole bunch of Pro Minis to it. And these are like $12.
Just kind of look at everything we would need to think about if we were going to use, start mounting these Arduinos on our layout. So.
Well, you could either use a dedicated power supply with a 5-volt bus, like what I'm talking about here, or for our test case, what Dave's got there is the right way to do that. And that come with most of our kits, these little accessory power boards. They're great for using with our breadboards. That's the right way to do that for development. But if you're going to permanently install it, you either want a 5-volt bus, or if you have a 12-volt bus, then you can buy these little regulated power supplies, probably on Make Good for like $1.99 or $2 or $3. You can buy a little bitty regulated power supply that will drop that 12 to 5.
So what you're telling me is the Pro Mini is limited to a 5-volt input, unlike the without, like on your Uno, we can just plug in, like, I think it's up to 12 volts or something. Definitely Dave's got a 9-volt plugged in right now.
Yeah.
And I think my Walmart, I think, is like a 12 volt, close to the max. But so what is the maximum input voltage on a Pro Mini then?
I think it's like 4.5 to 5.5 or something. It has a range as well, but it's a lot more limited than.
Okay, so you definitely have to make sure you're stepping down before you.
Yeah, they come in. The Pro Mini
using
comes in
12.
3.3 and 5-volt logic.
Yeah.
Yep.
I'm using 5s, but yeah.
Right, but for that 5-volt logic, how much, what's your power supply?
Well, I'll show you
Maximum
here.
5 volts.
Take a look at my
At least 5
screen here.
volts, but
I've got 2 different power supplies that you can plug in. They're called buck converters in many cases.
Yep.
This is this buck converter here. The big one with a screen, it actually shows the voltage on it, and you can control the voltage, and it'll, so it's got a voltage display on it. But this little tiny buck converter,
that costs more than about.
pardon? This buck
Not
converter
much, but
here
probably.
is only about, I think I got 5 or 6 of them for $6, about $1 a piece, and you can adjust that to be 5 volts, and it'll kick out up to like 2 amps of power.
Wow.
Okay.
So it's not bad. You can feed it 12 volt supply, and it'll regulate it down to the 5 volts that the Pro Mini needs.
Perfect.
A difference in a buck converter, I'm not sure about this, Dave. The difference in a buck converter is that it does polarity verification, right? So you could feed it 12 volts either way, and it will always give you the correct positive and negative. That's a difference in a buck, right?
No, I don't think so. A buck converter it's called a buck converter just because of the way that it converts the power.
Okay, all right.
And
So does the Uno then have that built in? Is that the difference? Is that basically have a built-in buck converter?
It has it has a voltage regulator. The Arduino has a voltage regulator, not a buck converter.
Okay.
But voltage regulators can, well, actually, I should say this: the buck converters do have the possibility of kicking out unwanted radio signals. So if you're in an environment where something is real sensitive to random radio signals, then a buck converter, you'd want to stay away from that and go with a regular power regulator. But the reason you go with a buck converter is they're very efficient, as opposed to a power power regulator.
Voltage regulator. Yeah.
Voltage
Cool.
regulator. Because voltage regulators, they waste a lot of energy. And I have some
Okay,
of
so that's a
those
good
too.
little education. If I want to go on, what I'm going to do from now on, and I apologize for not doing this on some of the previous shows just because I've been so busy, but I want to you guys start checking the G Plus, Hangout board, or not the Google Plus site for YouTube model railroaders. I'm going to start posting a week in advance at least what we're going to be covering and what you might need to. But I think I'm going to go ahead and post up a couple of weeks to give you guys a chance to get them, and let's get some Pro Minis and play around and try and use them. And I'll talk to Dave again offline just to make sure I got everything on the list, and we'll see what we need to order for a couple bucks. A buck converter and a couple Pro Minis. I would think for about $15 we should be able to have everything we need to have 5 Pro Minis and be able to program them and have a voltage regulation. Huh? Anything else we need to worry about there, Dave?
No, that's about it.
I'll give them the 2 options, the price. I'm assuming obviously the one with the little.
Let me give you a suggestion though. I tend to like to buy these boards. If you look on eBay or even out at Banggood, you could buy them with this and a power supply like this and a pack of wires for $5 or less.
Oh wow!
You could buy that whole thing, and so I'll buy 2 or 3 kits of that, and so I'll have 2 or 3 power supplies, and then you have a new breadboard to go with it and more jumpers.
So I see. Is that a USB connector on there too, next to on the opposite side? Yeah.
You can
So can you
power.
program?
Yeah, you can power a regular Arduino off of it. That way, you can take a 9-volt battery and power your standard USB input of your Arduino Uno or something with it, or you might even charge a cell phone or something with it. It's an output though, not an input.
Oh, it's
No,
an
I
output.
thought that was actually an input.
Well, okay, and I'm not saying you can't use it as an input. I don't think you can, but it does work as an output. And to use that as an input, that's a really odd cable to buy an A to A. You could buy them, but you can't just go to Walmart or something or Best Buy and buy an A to A cable. Those are kind of odd. I have one. I had to order it for something weird, but that's a fairly odd cable to find. Most USB cables are A to B, like the one we use for our Arduino stuff. That's a B. The standard,
I have a
rectangle
whole
one's
lot
an
more A
A.
to A's. A to B's are the ones I always just run short on. I don't have a ton of A to A's, but I
You
don't.
can get these adapters that are really handy that have that have an A on one side and a B on the other. These are kind of handy for stuff that we're doing here. But an actual A to A, male to male cable is a really odd cable, but you can find it.
I find A to A, male to male all the time. It's the A to Bs that are hard. You must just have it
Yeah,
backwards out there in Kentucky, buddy.
I guess so, because I've got a million A to A's. It's the A to B's that I got to scavenge off of printers and things like that.
But you can find A to micro A to mini A, and A to female A. But a male A to a male A. What do you have that uses a male A to a male A?
Well, I've
You know
got
what,
one
Andy?
sitting
I'm on
right-
your side. I'm on your side, Andy.
Just because I argue my point the strongest is all. But
No. I can't say that I have any A to A cables. And
I
now
ordered
that I
one.
look at it.
It's hard for me to even find it. I found one, but I had to order it online somewhere, and it was all for an old external hard drive that somebody had, and they wanted me to get some data off from it. And with the first USB, I mean, it's like one of the first USBs. When USB 1.0 come out, and it was a really small hard drive that took like, a decade to put a movie on. And it had an 8A cable. I've never seen anything else ever use an 8A.
Yep,
Okay.
I'd agree with you.
Well, you guys, I think we're pushing our time here, so I'll come up with something good for the next show, and I'll get it posted up within the next week. All the input, and guys following along out there on YouTube, and say any questions or anything you want me to cover, it's at gmail.com.
Actually, Chris, I think I just got to throw out again. I like the idea of the Arduino tortoise control.
I do too.
And
Okay.
I mean, I don't know if Andy, if you have time to get something like that up, because I think
I
that would
can
be
work
a
on
lot
that
of
too. I
benefit to
have
a lot of people.
I have tortoises here. I can work on that too. That should be fairly simple, I would think.
I don't have a tortoise because I'm using servos, but I could order a tortoise. Wouldn't hurt my feelings. Order would. Either way, the circuit that actually has to drive that switches polarity, that I can build easily and show you the polarity switching.
Yep.
Yeah, just let the Arduino do that even. Question is, how do you want to control it? Button, do you want to be able to throw it from a throttle? Do you want to...
I would say a toggle switch, off on toggle switch.
Yeah, have you guys covered push buttons?
Yeah, we did a push button show already.
I'm sorry, I missed a few shows, so I probably missed that.
We covered buttons and a debounce. Yep, exactly. That was a couple shows back.
Yeah, and I've already wrote the logic for doing a servo. Actually, not it. Well, whatever. Or using the bounce to toggle the state. So I could take that bit of code and instead tie it to a simple circuit that reverse polarity on toggle state. So when you hit the button, it's power this way. When you hit the button again, it's set power this way.
Yeah, so that's exactly what this is pretty much right here. What the remnants of it when I did that. The push button, you push the button once, it's red LED. You push the button again, it's green LED, and that would work perfect.
We have to do with with the tortoise is you've got to send. It's not on here or on here. It's you're.
It's like two relays. You almost would need like two relays, wouldn't you?
Yeah, you need two transistors, and again, this is just my thoughts. I haven't actually thought about it much, but just a quick thought when we were talking about it earlier was a couple transistors and a diode as a safety measure to make sure they don't both come on. So a diode would force them to be in either one state or the other.
I would.
Yeah, and I kind of got overkill with stuff. I ordered diodes.
A little bit overkill.
And I ordered a few resistors too, but this is the problem with, like, I'm pretty sure I ordered these off Make Good. This is 20,000 resistors of 20 different types or so, but it's 20,000 resistors, and it was $13.
Jeez.
Yeah.
Wow.
So I won't need resistors anytime soon, but I mean it's like
yeah. I mean, I'm looking here now and at the stuff that they have, and I've ordered one thing from there before, but I'm looking at and people are reviewing on them. There's like 66 reviews, 36 reviews on all this stuff. So I mean, people are buying it and using it. So
The baked good
I haven't had it.
Baked good is so in China you can't just take an American service and just put it there. It's really difficult. Google had a lot of trouble with it. So China has equivalents of U.S. services, but we can still use it in the States. So baked good is the Chinese equivalent of Amazon, and Alibaba is the Chinese equivalent of Google and Google services.
All right,
I
got
haven't
one
had any
question
bad luck.
here. Dan B and man, have y'all covered the rotary switches yet?
No, we haven't.
And a rotary encoder would actually be really interesting to cover too, because
Yeah,
there's a
'cause
lot
I
of
don't-
things to do with a rotary encoder.
Yeah, rotary switch itself, I guess, if you wanted to just change outputs, boom, 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 you know. But that's
Well, what might
kind
be
of thing to
interesting is to use an
be
Arduino.
fairly easy to do without an Arduino, but yeah, something like a rotary encoder.
Yep, but you could take a rotary encoder and use it to tell the Arduino something and either fire different LEDs depending on which position that rotary encoder was in, or index a turntable, or there's a lot. That's what I would have used a rotary encoder for.
Right. Well, and that's probably what he was getting at. He's probably thinking about the turntable and using that as the input device for the turntable. But I'm just,
Might
because
be
then you
great
would
for a
need,
yard ladder. For throwing the switches on the
Yeah.
yard ladder.
You know, you could
to
use
do
two
a
for that.
toggle off, do a switch and toggle back on, because you don't want to be hitting each of those contacts as you turn it.
I think what you would want to do if you were going to throw a yard ladder with a rotary is you'd want to turn the rotary to have like a rotary and a momentary contact button or something. So you would have
Yeah,
it's like a code button on a CTC panel. So you'd turn the rotary button to track 7 and tap the button and it would align all the turnouts.
Yep.
Yeah, that's exactly what I was saying. You don't want to be running across, wiping through each macro as you go. You want to turn it off, turn the rotaries, turn off the connection, so to speak, dial the rotary, and then turn it back on. Or like you said, just momentary push button.
If I was going to build a turntable indexing system, I wouldn't use a rotary decoder. I would use like a keypad, and I would make every position on the turntable a number, an ID of 1, 2. So say 2 would be like 90 degrees, 3 would be 95 degrees, whatever. It wouldn't be that far apart. But what I'm saying though is that way you can index your turntable so that when you go to hit, when you bring your locomotive in from the siding into the turntable, you hit 4, you send it around to the roundhouse, and you can put it right in. You don't have to try to line the tracks up all the time. You already pre-programmed it.
Well, see, the rotary encoder, so a rotary encoder is not really a knob in a meaningful way. It's like a volume knob or a potentiometer that is more like a stepper motor than anything else, because it tells you exactly where you are instead of closely. And what I would use a rotary encoder for on a turntable, like when I build my turntable and use a rotary encoder, it's not for controlling it. I'm not going to have a knob there that controls it. JMRI or whatever will control it. But the rotary encoder is on the thing to index it so that it tells you very, very accurately when your rails are aligned into track 11.
Well, what I'm saying is you could do that. You could do that with a keypad.
Well, I'm saying
Yeah,
what I'm suggesting is that it would be on the shaft of the stepper motor going up to the turntable bridge. And as that rotary encoder is just a ring going around that, basically. And then as the bridge turns, the rotary encoder tells the Arduino very, very precisely where it is. So it's an indexer, not a controller. Now, how you control it, rotary switch. And if I was to use
Andy, you're saying about using the rotary encoder to find your position.
Yes.
Of to find the actual position of the turntable.
Yes.
And the other response is to
it's like feedback. It's a feedback loop. And with the stepper motor, which is quite accurate but not perfect, and the rotary encoder, using those two in concert together, you can get very, very accurate indexing.
Well, I tell you what, we're about to hit the witching hour, and this would make a real good discussion when we get into trying the rotary decoders or the rotary switch.
And I just to cut in for 1 second, I think Chris had a great idea. one thing that didn't come with our kits that we should probably cover is keypads. You can buy real dirt cheap little keypads for inputting your Arduino. You know, that's another thing to look at when you go out at Banggood or eBay next time.
Yeah.
So, make a good show, man. All right, Johnny, thanks. I'll let you close us up, and thank you everybody for participating. Another great show, and appreciate everybody being here, and I hope you learned something. And we'll
Yeah.
give
Andrew.
Johnny a couple seconds here.
Yeah, Andrew got me choked up here.
Yeah, you're all choked up about having to turn us off for the night.
Now, Andrew's got an aftershot started up for everyone that's not in Australia. That's an after show. If y'all don't know, Andrew and I are all the time poking at each other. So, yeah. He got to typing a little too fast there. Let me get back over here. Alrighty. Appreciate it, Chris. Another good show. Appreciate everybody being in the chat. Appreciate everybody on the panel here tonight. I want to say go to youtubemallbuilders.com. There you can check the schedules. Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern. The Thursday and the Saturday show are 9 o'clock Central, 10 o'clock Eastern. And we got a Thursday night show tomorrow night, general talk show. And this Saturday, we've got the Saturday live show with Big Bill and Barry. So you don't want to miss that one. And, well, I just lost my train of thought here. Click on the eMag tab. I know JD's going to be texting me about that one. Be sure to click on the eMag tab while you're there at youtubemallbuilders.com and sign up for email notification. So when the eMag comes out, you'll be notified and you can go download it. That is a free publication with no advertising. And it's all for the community, by the community. We got some really good people send in articles. JD and his team do a great job of putting in the magazine. So you definitely want to check that out. Also, all these shows are recorded. We got a few new people in the chat tonight. Y'all were talking about a few things that we've already covered. You can go to YouTube Mall Builders on YouTube. We do have playlists there. You'll find the Arduino playlist, and you can go through and catch up on the shows and what they've been doing, especially with push buttons and all like that. So hope you enjoy, and we shall see you later on. Tomorrow night's the Thursday night general hangout, and then Saturday is the Saturday live show with Big Bill and Barry. So you be sure to want to catch that one. All right, good night.